In the era of artificial intelligence, data centers are the unsung heroes powering the digital revolution. But their thirst for water remains a silent yet significant concern. These massive facilities, which house the computing power behind our online activities, are notorious water guzzlers, with corporations often keeping mum about the exact quantities they consume. Let's delve into the water footprint of data centers, a topic that is gaining momentum as AI technologies advance and the demand for data processing capacity skyrockets. Imagine a world where data centers, the backbone of the internet, are expanding at an unprecedented rate to accommodate the surge in AI applications. These centers, besides requiring vast amounts of electricity and space, also need substantial volumes of water, a fact that is often overlooked. Water is crucial for cooling the high-performance computers, which generate enormous heat while processing data. Moreover, the electricity generation to power these facilities also demands water, particularly when the energy source is fossil fuels, as opposed to renewable options like solar or wind. A recent study by the Lawrence Berkeley National Laboratory reveals that in 2023, U.S. data centers directly consumed approximately 17 billion gallons, 64 billion liters of water for cooling purposes alone. Looking ahead to 2028, this figure could potentially double or even quadruple, reflecting the rapid growth of the industry. Additionally, the indirect water consumption associated with generating electricity for these centers was estimated at a staggering 211 billion gallons, 800 billion liters in 2023. However, these figures are mere projections in an industry that is constantly evolving. As researchers specializing in water law and policy, based near Lake Michigan, we've observed a trend where technology giants are eyeing the Great Lakes region as a prime location for new data centers. This includes a proposed project in Port Washington, Wisconsin, which could become one of the largest data centers in the nation. The Great Lakes area is attractive for hosting data centers due to its cooler climate and abundant water resources, making it ideal for managing the heat generated by these facilities. However, the Great Lakes are not just a reservoir for data centers. They are a vital resource shared by over 40 million people who rely on them for drinking water. The lakes support a regional economy valued at $6 trillion, underscoring their significance beyond mere water storage. As data centers move into the region, they will compete with existing water users, potentially impacting local groundwater levels and affecting communities that depend on these waters. Our investigation into public records, government documents, and sustainability reports published by leading data center operators has uncovered a lack of transparency regarding water usage. In an upcoming article for the Rutgers Computer and Technology Law Journal, we outline our methodology and findings, revealing that tech companies are not always forthcoming about the water demands of their data centers. Corporate sustainability reports have proven to be the most informative source, offering detailed insights into water consumption. For instance, one data center in Iowa used 1 billion gallons, 3.8 billion liters of water in 2024, a volume sufficient to supply all of Iowa's residential water needs for 5 days. Such revelations highlight the scale of water usage by data centers, which can account for over 25% of a local community's water supply in some cases. Data centers employ various cooling techniques, each with its own water consumption profile. Evaporative cooling systems, for example, use water to absorb the heat generated by servers, converting it into steam that is then released into the atmosphere. This process requires a continuous flow of water. Alternatively, closed-loop cooling systems utilize air-cooled chillers to cool the water, which is then recirculated, reducing the need for constant water replenishment, but increasing energy consumption. Unfortunately, detailed data comparing the water usage of these different systems is not publicly accessible. A critical aspect of assessing water usage is understanding the concept of consumptive water use, which refers to water that we focused our analysis on 6 major tech firms: Amazon, Google, Microsoft, Meta, Digital Realty, and Equinix. Our research highlighted significant disparities in both the volume of water used by their data centers and the level of detail provided in their reports. While sustainability reports shed light on data center water usage, the voluntary nature of these disclosures means that companies report varying metrics, making comparisons difficult. Notably, these reports often omit indirect water consumption linked to electricity use, which, according to the Lawrence Berkeley Lab, was roughly 12 times higher than direct cooling-related water use in 2023. Our analysis focuses solely on direct water consumption for cooling purposes. Among the companies analyzed, Amazon publishes annual sustainability reports, but refrains from disclosing specific water usage figures. Microsoft shares data on its overall water demands, but does not specify water usage for data centers alone. Meta breaks down its water consumption, but only provides a total company-wide figure. Google stands out by providing individual data center figures, showcasing a commitment to transparency. Across the board, the 5 companies that disclose water usage exhibit a common trend: a steady rise in direct water consumption each year. This increase is attributed to the expansion of data centers to meet the escalating demands of AI technologies. Taking a closer look at Google and Meta, 2 companies known for their detailed reporting on data center water usage, reveals intriguing insights. In 2023, Meta consumed 813 million gallons of water globally, 3.1 billion liters, with 95%, 776 million gallons, or 2.9 billion liters, allocated to data centers. Similarly, Google's worldwide operations consumed 6.4 billion gallons of water, 24.2 billion liters. In the same year, with 95%, 6.1 billion gallons, or 23.1 billion liters, used by its data centers. Google's data center in Council Bluffs, Iowa, was the thirstiest in 2024, consuming 1 billion gallons of water, 3.8 billion liters. Meanwhile, the Pflugerville, Texas data center, which employs air cooling instead of water cooling, consumed a mere 10,000 gallons, 38,000 liters, equivalent to the water usage of a single Texan household over 2 months. This data center's water consumption pales in comparison to the 1.5 million gallons, yet without a standardized and transparent framework for monitoring water consumption trends over time. Policymakers and the public will be left in the dark regarding the true environmental impact of these colossal, water-intensive structures. This knowledge gap hinders informed decision-making on matters such as site selection, regulatory frameworks, and sustainability initiatives, leaving communities and ecosystems vulnerable to the hidden costs of our digital age.